Shanti-Peace for Mathematics. This video is based on the solving of example using method of Lagrange multipliers. Let us state what is the example is, so that a rectangle solid of maximum volume that can be inscribed in a sphere is a cube. So the question is, you have given one sphere and you have to fit one rectangular box into the sphere. Okay, so you have to fit this rectangular box into it. The question is, you have to prove that this rectangular box you can fit with the maximum volume if it is a cube. So that means you having the problem to maximize the volume of a rectangular solid. So that is the volume of the rectangular solid. If I can assume that the length, breadth and height will be x, y, z, then the volume will be x into y into z. So by simplicity, what I am assuming is the height is 2x, 2y, length is 2y and breadth will be 2z. Because it will reduce my calculation, so that's why I am just adding 2 here, and so the volume will become 8 into x, y, z. Now what is the condition is given? The sphere is a fix. So I will fix the radius of the sphere. Let's say the radius of the sphere will be capital R. So, and the equation of the sphere, and I am fixing the center of the sphere as a 0, 0, 0, that is origin. You can have, if it is not at the origin, you can shift your coordinate at the origin and you can do this calculation. So for simplicity, I am just taking that center of the origin as 0, 0, 0. So that's why the equation of that sphere having the center 0, 0, 0 and radius is r. R is a fixed parameter. That is x square plus y square plus z square is equal to r square. So this is the given condition, and you have to maximize the function v, which is 8xyz. So let us recall what is the method of Lagrange multipliers and what is the working rule for that. The working rule for that, we have this. We need to have the function f, which is f plus phi, lambda phi, where f is the function for which we need to calculate the extremum value and the phi is the given condition. The second step is to calculate these equations, and the third step is to solve these three equations together with phi of x, y, z. And if you can solve that one and you can have the value of x, y, z and lambda, that value of x, y, z, it gives you the stationary value for the function f of x, y, z. Let us try to solve now for this example, where this is your f and this is your phi of x, y, z. This is phi of x, y, z and this is your f of x, y, z according to the working rule for Lagrange multiplier. So what is your capital F? It is 8xyz plus lambda into x square plus y square plus z square minus r square. Now we need to calculate what is fx equal to 0 will implies 8yz plus 2x lambda equal to 0. Fy equal to 0 will gives you 8xz plus 2y lambda equal to 0. Fz equal to 0 implies 8xy plus 2z lambda equal to 0. Now these three equations will gives you this. If I multiply the first equation by x, the second equation by y and the third equation by z, then these three equations, first equation will become 8xyz equal to minus 2x lambda. The second equation also have 8xyz because this y is multiplied to this, so that is 8xyz equal to minus 2y lambda. And the third equation will have 8xyz minus 2z lambda. So I have forgot to multiply this x to this x square. So this is x square, y square and z square. And if you just see this 3, that will gives you x square equal to y square equal to z square, and that will implies x is equal to y equal to z, because the negative value we cannot take, because this x, y, z are the length of the rectangular boxes, that is length, height and width. And since x is equal to y equal to z we obtain, we can say that using the Lagrange multiplier method, we say that the length, breadth and height is equal. So your rectangular solid is nothing but the cube. So that completes the solution for this example. That's it for this video. If you like this video, please press the like button. If you have any questions, suggestion, then please write down in a comment box below. If you are new in this channel, then please subscribe to channel Shanti-Peace for Mathematics. See you in next video. Bye bye. Sayonara.